Hello, this video is a progress report made by two leading institutes of the University of Stuttgart in the area of industrial automation and manufacturing. IAS, Institute of Industrial Automation and Software Engineering, on the one hand, and ISW, Institute for Control Engineering of Machine Tools and Manufacturing Units, on the other hand, joined the forces to develop two intelligent and connected model factories for teaching and research purposes. This project was funded by Mobility of the Future Innovation Campus, Innovationscampus Mobilität der Zukunft, in short ICM, and we would like to highlight that ICM not only provided the generous budget for the hardware of the model factories and for the students working on the assembly of the factories and on the development of the software, but also shared our vision on the software-defined manufacturing of the future. The right part of this slide shows the ICM vision, defined as intersections of three technological domains: manufacturing systems, mobility technologies, and software system architectures. This project lies in the intersection of manufacturing systems and software system architectures. However, mobility technologies are also touched, since we have mobile robotic platforms in our model factories. Modern and future manufacturing systems shall be high-performing, flexible, and of course safe. This can be achieved by shifting the focus from the hardware components to the software technologies that can enable the development of reconfigurable and modular production systems. The intersection of manufacturing systems and high-end software technologies leads us to a new concept: software-defined manufacturing. The transition from the classical production systems to the software-defined systems is sketched on this slide. In traditional manufacturing, we are talking about fixed production lines assembled using single-purpose machines with rare software updates. The disadvantage is the lack of flexibility. Software-defined manufacturing is centered around the idea that software is decisive for the production line configuration. We have production lines consisting of multi-purpose robots that can easily switch from product A to product B with the next software update. Software-defined manufacturing follows the concept of cyber-physical systems, when we have our physical assets and an extensive cyber representation of our system in the form of a digital twin. Despite the fact that SDM is a rather new concept, it is necessary to already start preparing engineers who know this concept and can develop and operate such SDM systems. This is the primary motivation behind this project. Following this motivation, we are developing two model factories, one at ISW and one at IAS. They both will be integrated into a single digital space. A user will be able to control both factories from a single interface and customize production according to the SDM concept. These factories will primarily be used for education purposes. However, we also plan to do research using these factories. Both institutes will focus on digital twin development, industrial robotics, and application of AR and VR technologies. In addition, ISW will concentrate on model-driven development and IAS on the risk modeling of the SDM systems. The factories will be used as hands-on models during the exercises of relevant courses of the institutes. At the moment, the main components of the factories are already acquired and assembled. They are created on the basis of Fisher Technic components, extended with mobile turtle bots and Revolution Pi controllers for the factory assets. On the left side, you see the mini factory of IAS, and in the right side, you could see the video of the mini factory of ISW. The turtle bots are equipped with manipulators, for pick-and-place tasks. Currently, simple pick-and-place ROS-based algorithms are implemented. The Fisher Technic components, all those red conveyor belts, grippers, sorting and punching machines, are controlled with special Revolution Pi controllers. These controllers allow us to control several assets from a single controller with easily understandable Python code that reads sensors, light barriers, impulse counters, buttons, and so on, and controls the encoder motors and other actuators of the system. The manufacturers model a customizable production process that will be set up and executed by a user using a web interface of our digital twin. The process will be visible with AR/VR glasses. At the moment, only the basic control software of the factories is developed, and the cyberpod, the workshop, and the AR/VR are the tasks for the next year, 2023. The layout of the factories in EIS and in ISW are slightly different, since our institutes want to focus on different aspects. ISW on the model-based development and EIS on the risk assessment. However, the factories will simulate a joint production process where the parts will be virtually transferred from one factory to another. Let's summarize the results of the future plans. The physical part of the factories are almost finished. This is the key achievement of the year 2022. The development of the cyber part is, let's say, the task of the year 2023. In 2022, we acquired all necessary hardware components, including all Fisher Technic components, Revolutionary Pi controllers and extenders, turtle boards, manipulators, tablets, and several sets of HoloLenses for AR/VR. We assembled the main parts of the factories at EIS and ESW that were shown in the videos in the previous slide. We tried several controller solutions and stopped on these Revolution Pi controllers. We developed basic control software for the Fisher Technic components so that the factories can run their basic functions, as well as a simple pick-and-place ROS algorithms for the turtle bots. This is what was planned for the 2022, to create the basis for our SDM. In 2023, we will implement the cyber part of our system. We will develop the cloud that will contain the digital twins of the factory assets of both factories integrated into one single cyberspace. We will develop a web interface that allows our users to control and to execute the SDM production process. We will develop the HoloLenses software to visualize the process using AR/VR. Last but not least, we are optimistic and plan to start our first teaching activities at the end of 2023. Thanks for watching, and we would like to say thank you to the ICM Innovationscampus Mobilität der Zukunft for supporting our vision on software-defined manufacturing with generous funding for the required hardware and for our students who assemble the hardware and develop the basic software. Thanks for watching, and see you in 2023.